All right, welcome, ladies and gentlemen. My name is Brian McLogan, and we have another live Q&A for you guys tonight. So I have 5 problems that I'm going to work on, and then if I'm able to get to some more, then I'll be happy to do that. But usually, typically on these Sunday nights, I try to go ahead and just spend about 30 minutes, answering some of these questions. And I wanted to kind of let you guys know of things. Sorry for being a little late, and also I'm not really sure why my YouTube is saying it's being. I was in San Diego over the weekend, and so I'm assuming that maybe like my internal clock on my computer or something was getting messed up. Because obviously I know some of you, if you might have been getting the notifications, maybe we're especially on like the West Coast or a different time zone, then obviously that would have been showing up to you guys as far as, you would have been planning on a different time. But my live streams typically like to go at 9 p.m. Eastern Standard Time. And the reason because that gives hopefully my daughters enough time to go to sleep. However, what's been happening in the last couple nights is they have not been going to sleep. So therefore, that's why my live streams have been delayed. But it's also something important that I just want to let you guys know of, and I am more than happy to take into some considerations. I've done some research on my own, trying to see what is the best solution for you guys to be able to submit problems for me to solve, because I don't really feel that the community chat is the easiest thing, because you guys can't confirm back to me. We actually can't have a dialogue when you submit a question. So I don't really like the community chat for you guys submitting questions. If you submit questions once I post the live stream, again, it's kind of hard to type in your question. And then also if I lose connection or anything else, then I don't have the active stream, and it's hard for me to go back into the chat anyways to be able to find your questions. And then some people have been doing Facebook, which I like, but not a lot of people have been interacting with the Facebook. So I'm not sure if there's a better way for people to submit their problems and their questions. So therefore, I will take the advice of you. And if you guys have anything that you're aware of, or maybe you've done something similar, but obviously something that would be free and easy for people to use all across the world to be able to submit their questions. But so anyways, if you know of anything or you have an idea about that, please feel free to put that into the chat. I will make sure that I take a look at that. Let me just make sure. I'll make sure I go ahead and take a look at that and kind of see if I can maybe make some updates for you guys throughout the year. Because we're in week 10. I can't believe I've made actually 10 live streams so far this year. Just open Q&As, not even live streams that I'm doing in my class. Just open Q&A. I'm here to answer your questions. However, what that brings up to me again is another last minute point before we get into this live stream is, when you guys are submitting your questions, it's at least easier for my brain. You guys got to understand I set the live stream, and then sometimes based on how my day is going, I might not be able to get to your topics or your questions, until about maybe like 30 minutes before the stream. So if it's not something that, obviously I try to check in earlier. So, cause some problems I like, I just want to make sure I work through them or I verify some things. And, but otherwise, if it's not, or if I don't have an equation, to go off of, it's very difficult for me to be able to answer your question. So if you would like your questions, answered on here, if you can please just make sure you're very specific as far as the problem that you'd like me to address. Kind of like vague questions, even though they're not bad, it's just a little bit more difficult for me to kind of address them in a live stream format. That's why for the live stream format, I like to go off a specific equation. And there were a couple people that asked some questions that I provided equations to them because it was fairly basic. It's stuff that I've been most recently been doing. However, there's other problems. I'm like, I don't have time to either look up a problem or to find a problem that would help you. So if you have a problem that, addresses what you're dealing with, then that would be great. So anyways, that's a quick little housekeeping for you guys. I just want to make sure I'm not seeing why my chat is not popping up. It just kind of seems weird. Usually, actually, I know what I'm going to do. I'm just going to open up a new chat just so I can, because sometimes if I lose internet connection, no, it's like my chat is disabled. All right, well, I'm not sure why that is the case, but we'll just have to roll with it, I guess. There's always something. Oh, okay, here it goes into. All right, sweet. There's a lot of chat that I was looking into. Sweet. Yes. Now I see you guys. All right. A lot of chat going in there. Sorry, guys. I'm not going to get to all of you. But I do see CFL and Emily and Arcade and AJ, Arlie and Peyton, Axe 1010, Aisha, awesome. So very good, guys. And I know a lot of you that maybe didn't miss the early notification. You have some questions. I mean, feel free to put them back in the chat. I'm going to try to do my best. Obviously, I had to do a little housekeeping items here that I started talking with, so that's kind of taking away some time. But I'll try to answer some of those questions for you guys. But again, guys, it's either I'm going to have time or I'm not going to have time. You don't need to spam the chat, keep on repeating your question. I'm going to try to spend 30, sometimes every time I always go over, but it's usually only over 5 to 10 minutes. So it's not going to be something that I'm going to be able to get to a lot of your guys' questions. But that's why I want to kind of get some of that feedback from you guys as far as maybe some different ways that would be a little bit more beneficial for you guys to be able to respond to me with exactly what you are needing some help on. So anyways, let's go and take a look at the questions we're going to deal with here. Here we kind of have like a word problem. I really do not like doing word problems at all. So basically, if you send me a word problem, I'm not going to be able to do it, or I'll basically just say I'm not going to be able to do it. But this one really wasn't as much of a word problem, just as far as it was a different equation. And then I'm just going to work through kind of 2 examples out of the 5, I think, that they sent me. Then we're going to evaluate the cosine of 15 degrees using the sum and difference formula, or just the difference formula. Then we're going to write the 3 forms, the vertex, the standard, and the factored form of a quadratic equation. So right now you have it in standard form, and we're just going to basically write it in the vertex as well as the factored form. We're going to learn how to factor something by grouping. And then, let's just add on to this, because this is something I've, last time. So we're going to factor it. We're going to factor by grouping. We're going to write the linear factorization. And let's just write the linear factorization. That sounds good. And then the last question here is a rational expression, which actually my class is starting. I actually take apart the chapter on rational expressions and I make it its own unit. Just because I know so many students struggle with rational expressions, complex fractions, and all those operations, asymptotes, wholes. And we're also going to talk about wholes and asymptotes in this one. So with that, guys, I am going ahead and go and get started. I did want to give a quick little shout out though to Ballerina or Stefan and Brienne. They're supporters on my channel, which I just feel like I have to go and give a support, because that is one thing that I really do appreciate for you guys. I know a lot of my help has obviously helped you guys out, and I know a lot of you guys based on where you come from, what you're doing, obviously just be able to put in any kind of support. I think I have the lowest one is $1.99, something, and it's not something I expect for you guys to be able to do at all. Obviously, if it's something that you feel like it's worth to put, then obviously I greatly appreciate you guys putting in support. But that's part of the membership, and part of the reason why I was out of town this weekend is really just working on providing you guys more value, especially for those of you that are in that membership. And one of the things I've been looking for the membership was actually growing it, so therefore I could do a little bit more private live streams. We're not at that point yet, so obviously if that's something that is an interest of you, then that's definitely something that I'm looking into, and plenty of other things down the line to kind of just give you guys a little bit more added value than obviously just weekly live streams and my content. But with that out of the way, let's go ahead and get started. So we have this function p of t equals 50 plus 2500 t squared divided by 25 plus t squared, where p represents the population, t represents time. I think the word problem was talking about population of frogs on a conservation or blah, 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 blah. You don't really need to know, right? That's why I don't like doing word problems, because we just need to extract what is it we need, which is basically the equation, and we need to know how our variables are defined. So the first thing is saying, what is the initial population? So, P of t represents the population of these, I'm just going to say frogs, population of frogs with respect to t. Well, obviously, if t is 0, that means that would be our initial, period. So if we want to find the initial of anything, we're just going to do p of 0. Obviously, I guess, your initial could start at a different time interval. But for our case, we're just going to have 50 plus and 2500 times 0 squared over 25 plus, I got to sneeze, sorry. Oh wait, I can hold it. I got it. Okay. So anyways, as we put t 0, that's going to make the numerator 0. And obviously when the numerator is 0, everything is 0. So that we can see that the initial population here is 50 frogs. The next one is finding the average rate of change on the time interval, I believe it was in years, from 1 to 5. Now, the important thing, I didn't remember which one was included or excluded, so we'll just, I'll just kind of roll with that. But either way, if you remember the average rate of changes, that's basically the slope of the secant line. Now, I don't know what this curve looks like, right? But basically, this average rate of change is saying, all right, at 2 time intervals, we're going to have different populations. And basically, all we want to be able to do from there is find the slope. So if you remember, like, let's just kind of make something up. Let's pretend this is like an S-curve population. So here's like 50, right? Let's say it goes something like this, all right? So all I'm basically saying is, you know, if we had like, here's 1 and here's 5, right? If we wanted to find the slope of that line, so here's 1, here's 5. Remember what that is that's the change in the run under the change in the rise, right? Or the change in the rise over the change in the run. So basically what we need to do is figure out what the rise is basically the y values. So what you're going to do is you're going to figure out what is p of 5 minus p of 1. Now, I told the student I'm not going to have time, I don't have a calculator. I'm not going to have time to calculate this, but I'll at least show you what to do. So just like I did p of 0, which was easy, you're going to do p of 5 minus p of 1, and this is, again, represents the the average rate of change. And then just going to divide that by my change by run, which is 5 minus 1. And then obviously you just go ahead and figure that out, and therefore that's going to give you that approximation. There was another question which was like, what is the average rate of change at 3, right? Well, again, at 3 we're looking at an instantaneous rate of change, which basically means we're looking for the slope of the tangent line, which basically means we need to go ahead and find the derivative. So that's something that student would have been able to do based on their calculus, wouldn't have been able to find the derivative. And then there's another one with asymptotes, but without knowing the word problem, it doesn't really make sense for me to talk about it. I gave them some help that hopefully helps them out. All right, sum and difference formulas. We are not in sum and difference formulas for a while, so let's try to remember cosine of u minus v equals cosine of u times the cosine of v plus the sine of u times the sine of v. I'm just going to roll with that. I'm pretty sure that's correct. I've been teaching for a while, and I always have to remind myself, but I'm pretty sure that's my identity or my formula. Okay, so the reason why we need to use this formula here, or this identity, is because we don't know what the cosine of 15 degrees is, right? If you think about like on the unit circle, we know what, 30 degrees, we know 45, we know 60, we know 90, we know 0, but we don't have a value for the cosine of 50 degrees. Or if you think about this in terms of just like the special right triangles, right? We have a 30, 60, 90, and we have a 45, 45, 90. We don't have anything for 15 degrees. But what the sum and difference formulas allow us to do, or the identities allow us to do, is if we can combine two angles, then therefore we can figure out what the value of that is going to be. So for instance, I know that the cosine of 45 degrees minus 30 degrees is the same thing as the cosine of 15 degrees. I'm just going to use parentheses here. Right? Wouldn't you agree the cosine of 15 degrees is equal to the cosine of 45 degrees minus 30 degrees? Now, the nice thing about this is I know I can evaluate the cosine of 45 degrees and the cosine of 30 degrees, right? Because based on special right triangles or the unit circle, I can be able to figure out those values. So therefore, that's where we come up with this identity. And it's basically where this identity kind of works from is triangles with the unit circle, when you look at the proof. But for our sake, we're just going to basically plug these values in. We're going to say, all right, that's going to be u, and that's going to be v. So now, in this identity, wherever I see a u, I'm going to use 45 degrees. Wherever I see a v, I'm going to use 30 degrees. Now, just be very careful here. I'm not using negative 30 degrees. I'm using a positive 30, right? It's u minus v. So that's my u, and that's my v. So let's go ahead and plug it in here. So I have cosine of 45 degrees times the cosine of 30 degrees, and that's plus the opposite sign, sine of u, which is 45 degrees, times the sine of v, which is 30 degrees. Okay, so now we just need to go ahead and evaluate. For the sake of time, guys, I'm going to assume if you're doing these problems, you know how to evaluate these based on the unit circle. So I'm not going to spend my time explaining these values. This is going to be the square root of 2 over 2. For the cosine of 30 degrees, that is going to be 1/2. Got to get my unit circle. We're not there yet, so I'm not primed yet in my unit circle work. Sine of 45 degrees is going to be the square root of 2 over 2. And then the sine of 30 degrees is going to be the square root of 3 over 2. Okay, and now basically, guys, we're just going to go ahead and multiply them out and simplify. Now, there is some different variations here. We could just write this as square root of 2 over 4, plus the square root of 6 over 4. Obviously, we could also see that they both share a square root of 2 over 2. So another form is you could have factored out the square root of 2 over 2, which would have left with a 1/2 plus the square root of 3 over 2. You could factor out all the 4s. You could have written something like this, 1/4 times the square root of 2 plus the square root of 6. I've seen a lot of books write them in like a lot of different answers, right? So you could also have it as what that would have been. Yeah, square root of 2 over 4 times 1 plus 3. There's many different variations. So just make sure you're understanding of how you can manipulate them, because that's where I think a lot of students get actually trouble in this class or in this section is the multiple variations of the formula that we arrive at. But I'd probably say, these two are your two different ways. Oh, and actually, let's just do this. Or also like 1/4 times, I already did that one. Okay, yeah, never mind. All right, that one's good. So anyways, those are just some common forms that you would possibly see. All right, so the next one is write in the 3 forms. Let's not write that in the 3 forms because I already wrote it. How about we write in vertex form and then factored form, okay? So the vertex form, the easiest thing to remember from, that's a bad problem to write in vertex form, but you know what? Let's just do it. That's good. That's a good idea because I just released a video on completing the square, which was only easy completing the square problems. And so, that was just to reiterate the just main idea of completing the square. This one's not very difficult, but it's going to involve fractions. So therefore, a lot of people are not going to like that. But I like this because I think it's going to help for the factored form. And I think that's going to be important for us to understand here from the factored form of this. So let's go ahead and figure this out because it's not going to be clean answers, which is good. We don't always want clean answers for everything. Hopefully you have at least a basic understanding of what I'm doing, because otherwise I would want to use clean answers. And then see, that's the point. That's why I always want students to provide me with an example of what is it the problem like. I'm assuming the student has an idea of how to go from standard form to vertex form, standard form to factored form. I'm assuming, so therefore I just randomly chose this equation. However, if this student has no idea, then this is not a good equation for me to start with, right? If they have a good idea, then this would be a good example because therefore they can, kind of see me working through the steps. So that's why a lot of times you guys don't have your questions on the live stream, because I don't have a problem to go off of where I can see, what the kind of difficulty is. So therefore I can best address my approach, how I'm going to explain it. So anyways, for this one, if we want to write in vertex form, we got to complete the square. So remember, we're going to take that middle term, divide it by 2, and square it. So we're going to take our b. Remember, standard form, guys, is y equals ax squared plus bx plus c. So I'm going to take b divided by 2 and square it. So that's going to be a -3 divided by 2 squared. That's going to equal a positive 9/4. So y is going to equal x squared minus 3x. You're going to add the 9/4 to that to create your perfect square trinomial. And then you're going to have to subtract a 9/4. And then instead of writing 1, I'll just write 1 here. and then you still have that minus 1, right? You can't just like get rid of it. But the main important thing a lot of students don't like is if, 1, how did you get 9/4? I took the middle term, divided by 2, and squared it. And then just make sure if you're going to add it, you got to make sure you subtract it. Now this creates a perfect square trinomial, which is not as obvious to many of you. If you guys remember, or one thing that I taught, it's always x divided by b divided by 2 squared. So if I took this and I took -3 divided by 2, therefore that's going to be x minus 3/2 squared. And if you were to multiply that out, you would see how that actually expands out to give you that trinomial. And then I'm going to write this as -4 minus 4/4. So I'm going to rewrite here 1 as 4/4. So therefore I can write my vertex form as x minus 3/2 squared minus 13/4. And this is a problem that we will be getting to in my class a little bit later in the year. I decided not to cover it. in an early beginning of the year because we get to it and I didn't want so many students to kind of be lost. But there is your vertex form. Now, to find the factored form, that's a little bit difficult because, typically if it's factorable, like good to go, right? If this was like, -4, then you'd just say y equals, x minus 4 times x plus 1. Like, good to go. But one thing we talked about in our polynomials unit is these are the factors. We can find the zeros, right? If I said find the zeros, then you set your equation equal to 0. And therefore you could say x equals 4 and x equals -1. So if I give you the zeros, you can always write from the zeros, you can write the factored form. So, well, I don't have this in factored form, and this is not factorable. There's no two numbers that multiply to give you -1, add to give you -3. However, I can find the zeros here. If I set my equation equal to 0, I only have 1x. So I don't need to rely on factoring. That's the nice thing about completing the square is you can use your inverse operations. So if I add a 13/4, and you could also use the quadratic formula. You don't need to use this form. You could actually go back up here and use the quadratic formula, which might be easier. And actually, that is the way that I taught my students. But since I already completed the square for the first part of the question, I'm just going to go ahead and, finish the problem here. So complete the square on top and bottom. Remember to conclude plus or minus. And you can also break up the square root in the numerator and denominator. So therefore, it's going to be plus or minus the square root of 13/2, okay, equals x minus 3/2, and therefore x is going to equal a positive 3/2 plus or minus the square root of 13/2. Now, these are my zeros, just like this. So if I wanted to write this in factored form, basically what you're doing is you're going to take these zeros and set them equal to 0, which I didn't show the zero product property, which I probably should have. So therefore, you guys would have a better understanding of what I was doing if that was something you were not understanding. So let's maybe just do that. Put that over here. So you have that. The reason why you can find the zero so easy is because of the zero product property. Now you can see that x equals 4 and x equals -1. So if you can identify the zeros, you can write the factors. So here are the zeros. Then what are the factors? So that's vertex form. And then factored form. Basically, all I'm doing is instead of solving, I'm going to take my 0 and set it equal to 0, which then becomes the factor. So therefore, the factored form in this case would be a 3/2. Oops, I'm sorry. Be an x plus 3/2. And then you could do plus or minus, so you're going to have to do both. So I'll just do plus square root of 13/2 and x plus 3/2 minus square root of 13/2. So hopefully this was a good review for anybody that kind of has a basic understanding of what to do, but they might have been maybe a little bit hung up on those what to do, like when you have fractions and stuff like that. And anyway, that would be the general take. My main advice, though, if it was something simple, I would recommend, completing the square and then writing the factored form, probably using quadratic formula as well, if it's not factorable. Because if it's factorable, then you'd want to do that, right? But this was kind of like a sidebar. This was not part of the problem there. Okay, let's go ahead and get a move on because we're slowing down. Question number 4 says factor by grouping and then also to provide the linear factorization. So, I factored this rather simply because at least in my class where we are at is I'm expecting my students to be able to factor quadratic trinomials rather simply by now. And so in this case, we see that it's not a quadratic trinomial, right? This is a cubic polynomial of 4 terms. So therefore, we need a different approach. Now, the main mistake that students make is they change the problem. So it's very important when you're applying grouping, you're going to group the first 2 terms and the last 2 terms. But it's very important when you're grouping these terms. Notice when I'm adding these grouping symbols, you can't change the problem. So what you're going to do is you can include, like subtraction is the same as adding plus a negative. So you can add an addition symbol and then keep that as a negative 6x plus 12. Or my preferred method is just to factor out the negative and just change the signs of both of your terms. Okay, so this works and this works. The one thing you cannot do is do this. 2x cubed minus 4x squared, which happens all the time, 6x plus 12. Because if you were to distribute that negative, you get a negative 6x, but then you get a negative 12. That's not the same as our original equation, right? So don't do that. So you either making a plus symbol, like and change the subtraction to a plus and minus, right? Plus a negative, and then you can group the first 2 terms, or use it as a negative and then just distribute that negative across. Therefore, by factor by grouping, now since we've grouped the first 2 terms and the last 2 terms, now what we're going to do is just factor out the GCF. So in this case, you can see that they both share a 2x squared. And by factoring out 2x squared, I'm left with an x minus 2. Here you can see I can factor out again a 3. So if I factor out a 3, a positive 3, right, then I have that negative out there. So that's going to be a negative 3, and that's going to leave me with a x. That's not right. Why don't we subtract out a 6? A little bit higher. There you go. And the reason why I knew that was wrong, because when you're doing factoring by grouping, if it's factorable by grouping, these 2 terms have to be exactly the same. So if they don't get exactly the same, it's either not factorable by grouping or you didn't do something right. And obviously I could see that I didn't do something right. Because now these 2 terms are the same, so I can factor that out. 2x squared minus 6. And therefore, why did I say I was going to do the linear factorization? Jeez, oh man, that was a bad idea. So that is your factored form. Let's pretend that if I needed to find the zeros though, and I had this like set equal to y, then if I wanted to find the linear factorization, again, I would set this equal to 0. Now this kind of brings back to my point though, of like what I was doing here. Like I can't factor that down any further. That's not a difference of 2 squares. It'd be great if it was, but it's not. So therefore the best way to do this is, yeah, I can set these both equal to 0, like x minus 2 equals 0 and 2x squared minus 6 equals 0. But again, once I know what my zeros are, I need to write them as factors. So to save myself some time, add the 6 divided by 2. I'm going to get x squared is equal to 3, square root, x equals plus or minus the square root of 3. Now this is a little bit easier. Those are my zeros. So therefore I can say my factors now, my factored form. I already knew that x minus 2. But this broken down, right now that's not linear. Those are not, that's a quadratic factor. So if I want to write these as linear factors, then basically what I'm going to do here, and actually, you know what I'm going to do here real quick. I'm going to factor out a 2 in this case. So let me actually change this one more time, because this is one of those big mistakes that a lot of my students had as well, is they made their mistakes here. What they did was they forgot about the scalars. So here you can see that these have a 2 in common. So I'm just going to take that out in front. And you can bring it all the way to the front. It doesn't really matter. X squared minus 3. There you go. Now use the 0 product property. And again, you recognize that 2 is just a scalar. So therefore, when 2 is just a scalar, we don't need to set that equal to 0. That's not a 0 of the polynomial. You can just set those factors there. The reason why that's important is because when you're writing your linear factorization, you just don't want to really rely on what the factors are. You also want to make sure that you have the scalars. Or I'm sorry, you don't want to rely on the factors from the zeros. You want to also make sure you have those factors. Because the linear factorization, multiplies out to give you a polynomial, right? And the biggest mistake that I had with my students in this chapter is they would find the zeros, then they'd go back and write the linear factorization, but they'd forget this too. And I always had to remind them, like, if you multiply this times this times this, that doesn't give you your original polynomial. You need to make sure you keep that scalar. So that's why I like to factor out any scalars you have and just remember them. Obviously, they don't impact the zeros, but they do. We do need to make sure they're included in the linear factorization. All right, last but not least, guys, and I know I do apologize. I'm kind of running a little low, and I do see some questions you guys are coming in there for, which is awesome. But I am, getting a little low on time, so I do apologize. I'm not going to be able to get to questions. But, one thing I mentioned, I'll have to go back through this chat, see if there have any guys added into, maybe some of you guys have been on the stream a little bit longer or, just kind of getting into the stream. But if you guys have any, maybe a good way for me to, for you guys to be able to send in your questions, so therefore I can address them. And again, obviously questions in the chat, guys. I mean, I don't do the live streams long enough for me to be able to look at a lot of your questions and answer them. It is something that I want to have done in advance, but I do think there's time for me to do more problems and for you guys to send me more problems that I can work on. So if you guys are able to, if you guys have any idea on the best way, software or whatever else that you guys could send me questions to be able to do that, then I would greatly appreciate that. Because right now the community chat, some people are writing questions once I first start the live stream or first start the notice of the live stream. Some people are doing Facebook. So I'm kind of all over the place, and I really like to have things, all in one place. So if you have any ideas, feel free to reach out to me, or, make sure you let it know in the chat, and then I will be looking through everything. And I do apologize. I'm seeing a lot of X's and numbers, which is awesome. I know a lot of you guys don't like that, but, pretty awesome to me, and I wish I could get some questions. So, from what's happened in the past, I know a lot of you guys do help each other out. So I really do appreciate for those of you that are able to kind of help other people, within the chat with their questions. Sometimes the questions are basic, sometimes a little more advanced, but everybody in this chat, what I've kind of noticed is from completely different levels. Some people I teach pre-calculus, but some people are way past pre-calculus in college, and some people are way below pre-calculus, in middle school and everything like that. So, that the fact that you guys can grab some value from me is, really humbling from my experience. But in the same respect, the fact that if you guys can help others that are in this chat, I really do appreciate it. So let's go ahead and wrap this live stream up, though. Let's get this last example for the rational expression, or rational equation, I'm sorry. And then I'll do a quick little talk on wholes versus asymptotes. So the quick thing that I wanted to go over with this, at least the way I teach it, is, we don't like fractions. Nobody likes fractions, right? So the best thing to do, or at least in my opinion to do, is just to get rid of these fractions. And to do that, we are going to want to multiply everything by the least common denominator. So the least common denominator is basically going to be the, not the least common denominator. We want to multiply everything by the least common multiple. Least common denominator is when we want to get to it's kind of the same idea, but we want to find the smallest number that 2x plus 3 and 2x minus 3 both divide into. So we're going to multiply everything by the LCM. So obviously we know that 2x plus 3 divides into 2x plus 3, and we know that 2x minus 3 divides into 2x minus 3. So it's not like a case of like 4 and 3, and you're like, oh, they both divide into 12 and 24. Polynomials, it gets a little more confusing for students. So I recommend from them, without trying to overly complicate things, we know that the product, just like 3 times 4 gives us 12, and 12 is a common multiple, 2x plus 3 times 2x minus 3, that product is going to be a common multiple, right, of both these numbers, as well as themselves is going to be a multiple, right? So just keeping that very basic from this point. Obviously, when I work through the examples, we work through different variations where you can see where you don't always want to just multiply the denominators. But for the sake, since we have this problem, I can see that there's nothing that's going to be smaller that both these divide into. So therefore, my LCM in this case is just going to be the product of 2x plus 3 times 2x minus 3. So what I'm going to do is I'm going to multiply everything times 2x plus 3 and 2x minus 3. So that's going to look like this. And I write it out. Like when I'm teaching this in class, I write the whole thing out. Because I want students to see why finding that common multiple is so important. What does that do when you multiply? Because again, you're just applying distributive property, right? So that's why you're having everything being multiplied. Because again, it's an equation. If you don't multiply everything, then you're not going to have an equation anymore. But the important thing is you can see that, of course, 2x plus 3 divides into this, right? The 2x plus 3's divide out. That's in the denominator. That's in the numerator. Of course, 2x minus 3 divides into that, right? That's in the numerator. That's in the denominator. Here, there's nothing in the denominator, so you're just going to have this product. So now I'm going to be left with 2x minus 3 times 2x minus 2x times 2x plus 3 equals the product of this, which is going to be a difference of two squares. So it'd be 4x squared minus 9. Okay, now the student gave me a problem where I'm going to have to do some distributing, some factoring, and then I'm assuming either factoring by solving or by the quadratic formula. So let's just go and see. Let's go ahead and distribute here and see what we got. So we have another 4x squared minus 6x. Hopefully I don't make a mistake. Another 4x squared minus 6x. And then let's go ahead and bring these over. Because I know if it's a quadratic, if I know I have to solve, then I'm going to want to make sure I set it equal to 0. So I'm going to bring that over, and then that'd be a positive 9. Okay, so here I get my 4x squareds. Those negative 4x squared, that's going to go to 0. Then I'll have a negative 4x squared. This becomes a negative 12x plus 9 equals 0. And kind of going into that idea of a scalar, I am going to factor out the negative. So I have a 4x squared plus 12x minus 9 equals 0. Okay, so if this is factorable, then I know it can be factored into a product of two binomials. And I did a video on this, where I talk about, trying to figure out what we can do for these. Now, the nice thing is I don't have many ideas here. I do see that my first term is a square term and my last term is a square term. So therefore, I could automatically think of these as a perfect square trinomial. So like 2x and 2x. And then obviously to give me a negative 9, though, that's not going to work. So it's not a perfect square trinomial because the last term would always have to be positive unless I made a mistake there, which I didn't. So let's see, that'd give you 18. Oh, okay, so maybe that could work. So maybe that'd be like plus 9 and then minus, 1. So that's not going to work. So 6 and 6. Yeah, it looks like it would work, but I'm not seeing that's going to work. So therefore, this person gave me a problem. I'm not seeing how it's going to be factorable. So therefore, we're going to use our other method to determine these zeros, which would be the quadratic formula. So I'm assuming I didn't make any mistake. Let me just go and check, and let's see if anybody in the chat saw how I did. Nope, I did not do, at least I'm not seeing anything, so awesome. All right, so let's go and do the quadratic formula. So remember the quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And again, guys, we can apply the quadratic formula only when we have a quadratic in standard form equal to 0, which in our case we do. Now, again, I don't have a calculator, so I was hoping this problem would have been a little bit easier for me, but I'll try to do my best here. So I'm going to use this form rather than the factored out the negative form, and therefore we'll kind of see what we have here. So opposite of b, that's going to be a 12, plus or minus b squared, which would be 144, minus 4 times a, which is negative 4, times c, which is positive 9, all over 2 times negative 4. All right, so now I'm really kind of curious. Let's see, that's going to be 16 times 9. Actually, I just want to pull out the calculator. I'm not going to do it in my head because this is the last problem, so that's not fair. But I do want to kind of see what that's give me and just see if I'm aware of that number. All right, come on. 16. Yeah, so that'd be, okay. So yeah, it's going to be an irrational number. So unless I made a mistake, which I could have, I will just allow the student with the calculator to go ahead and figure out or finalize that answer. But hopefully at least that that work made sense as far as what you do. Find the LCM, get rid of the fractions, get it to a problem. Typically, the problems we're going to do from this case is once you get it to a quadratic, it's going to be factorable and you can solve it because you're doing all of this work. However, it doesn't mean that it has to be factorable. Like you could use the quadratic formula. However, I would hope if you had a quadratic formula here, you can see it's a lot of steps. And since this is the last problem, obviously, I'd want to use a calculator and just make sure I finish it up. But either way, you're going to get that answer was like 288, square root of 288, simplified, and then you can just kind of go from there. But since I'm going to pass my time, I'm going to wrap it up there. And I do see a lot of you guys. I know the approach in there, so I really do appreciate it, guys. How do you factor when the coefficient of first term isn't 1? I'm not sure how I got to get you guys to get your questions in before time. So if you guys do have any more ways that you can help me out, because I see a lot of you guys are joining the live stream and you're ready. I mean, I've been going live for 10 weeks now at 9 p.m. Eastern Standard Time, and I will plan on going live again next week at the same time. So when you guys have these questions, please make sure you guys try to get them into me earlier, because I hate leaving this live chat with you guys having so many questions. But I also know I could stay on this live stream for all night, and I would always constantly get more people asking questions. So I do have to end the stream, guys. I do apologize for that. I really do appreciate for those of you that can help some other people out on there. That's great. And then I think the best thing is just going to have to be to move it into like a Facebook, or unless there's another platform that I see that you guys have maybe provided that we can help out. So either way, guys, that is where we'll have to end it from there. So I really do appreciate you guys joining the stream, and I will be back next week at 9 p.m. or at least I'll let you guys know. But yeah, we'll plan on being live next week here for another live stream, and I look forward to seeing you guys there. All right, have a good night. Cheers.